November 10th, 1943. Afternoon air hung cold and still over Rechlin airfield, Germany's primary. Luftwaffe aircraft testing facility sprawled across the flat. Mecklenburg landscape like a small industrial city. Hangars, workshops, administrative buildings, test equipment facilities, everything necessary to evaluate the Reich's aircraft and the aircraft of its enemies. The late autumn sun cast long shadows across the tarmac, and the smell of aviation fuel mixed with the scent of pine forests that surrounded the base on three sides. Hauptmann Hans-Werner Lerche, chief test pilot, walked across the concrete toward a Republic P-47 Thunderbolt that had been captured 2 weeks earlier. The aircraft sat there on the hard stand like an insult to German engineering sensibilities. Grotesquely fat, ungainly, a flying milk bottle, as German pilots had nicknamed it, with a mixture of contempt and dark humor. At 27 years old, Lerche had already established himself as one of the Luftwaffe's most respected test pilots. His slight frame, barely 165 centimeters tall and weighing perhaps 60 kilograms, belied his reputation for fearlessness and analytical precision. He wore his standard flight suit, leather jacket, and the calm expression of a man who had flown more aircraft types than most pilots would see in a lifetime. He had read the intelligence briefings before this flight. American aircraft were crude, mass-produced machines built by a nation more skilled at making refrigerators and automobiles than fighters. The United States was an industrial giant, certainly, but industrial might didn't translate to aeronautical excellence. American pilots were brave enough, the briefings acknowledged, but they flew inferior machines that relied on numbers rather than quality. The P-47 Thunderbolt was supposedly the perfect example of American engineering deficiencies. Heavy, absurdly heavy at over 4,000 kilograms, unsophisticated in design, relying on brute force, a massive engine, producing 2,000 horsepower, rather than the elegant engineering that characterized German fighters like the Messerschmitt Bf-109 or Focke-Wulf Fw-190. German fighters were precision instruments, the briefings explained, optimized for performance, built with careful attention to weight, drag, and agility. The P-47 was a sledgehammer, or so the briefings said. Lerche was about to discover something that would shake his understanding of engineering philosophy to its core. The Americans hadn't built a crude aircraft. They had built something far more dangerous, a practical one. An aircraft designed not for aces to break records, but for armies to break enemies through sheer overwhelming numbers and relentless operational availability. Within 90 minutes, Lerche would sit at his desk and write a report that would be filed and ignored by men who preferred comfortable lies to uncomfortable truths. But history would prove him right with brutal clarity. Germany was building fighters for individual excellence. America was building fighters for industrial war. And in total war, that difference would prove not just significant, but decisive. Hans-Werner Lerche had been flying since childhood, though his path to becoming Germany's premier test pilot had been anything but straightforward. Born in 1916 in Breslau, now Wrocław, Poland, he'd grown up in a family of modest means. His father worked in civil administration, earning enough to provide for the family but not enough for luxuries like flying lessons. But young Hans had been obsessed with flight from the moment he saw his first aircraft. He would stand for hours watching gliders soar over the Silesian countryside, studying how they moved through the air, how they turned, how they descended. When he was 14, he joined a local gliding club that operated with donated equipment and volunteer instructors. The gliders were primitive, wood and fabric constructions that required careful handling, but they taught Lerche the fundamentals of flight in the most unforgiving way possible. No engine meant no second chances. Every decision mattered. Reading the air, managing energy, understanding the relationship between speed and altitude. All of this became second nature to Lerche. Through hundreds of glider flights in his teenage years, he worked odd jobs to pay for flying time, saving every pfennig to buy additional minutes in the air. When Hitler came to power in 1933 and Germany began its secret rearmament in violation of the Treaty of Versailles, opportunities opened up for young men with flying experience. The Luftwaffe was being rebuilt from nothing, and they needed pilots desperately. Lerche applied immediately. His gliding experience counted in his favor, as did his natural aptitude and his obsessive attention to detail. By 1936, Lerche was flying powered aircraft. By 1938, he had been selected for test pilot training, a grueling program that washed out most candidates. Test flying required more than just skill at the controls. It required analytical thinking, engineering knowledge, the ability to communicate technical observations clearly, and a particular kind of fearlessness. Not the reckless courage of a fighter pilot, but the methodical bravery of someone willing to fly an aircraft that might have fundamental flaws, while remaining calm enough to diagnose those flaws and survive long enough to report them. By 1939, when the war began, Lerche was stationed at Rechlin, the Luftwaffe's equivalent of the American Wright Field or the British Farnborough. This was where new German aircraft came for evaluation. This was where captured enemy aircraft were tested and analyzed. This was where the future of German aviation was being decided. One test flight at a time. Unlike combat pilots who flew one or two aircraft types extensively, mastering every detail of their assigned fighters, Lerche flew everything. New German prototypes that existed in only one or two examples. Production aircraft being evaluated for modifications. Bombers, fighters, reconnaissance aircraft, experimental designs, and increasingly, as the war progressed, captured enemy planes. His logbook would eventually record over 120 different aircraft types. He had flown British Spitfires and Hurricanes, Soviet Yak fighters and Ilyushin bombers, and American aircraft, P-38 Lightnings, B-17 Flying Fortresses, and now this P-47 Thunderbolt. Lerche was not just a pilot. He was a trained aeronautical engineer, having studied during his early years with the Luftwaffe. His reports were known throughout the service for their brutal technical honesty. When an aircraft was inadequate, he said so clearly and without softening his language. When an enemy design was superior to a German equivalent, he documented it meticulously. This honesty had made him enemies among Nazi Party officials who preferred optimistic assessments to accurate ones. There were men in the Reich Air Ministry who wanted reports that confirmed German superiority, not reports that raised uncomfortable questions. But Lerche's expertise was too valuable to dismiss. When Hans-Werner Lerche said an aircraft was good or bad, people listened, even if they didn't always like what they heard. The P-47 Thunderbolt, sitting on the Rechlin tarmac, had an interesting story. The kind of story that happened more often than the Luftwaffe liked to admit as the war turned against Germany. Its pilot, Lieutenant William Roach of the 358th Fighter Squadron, 355th Fighter Group, had gotten lost in bad weather during an escort mission on November 7, 1943. His entire flight had become desperately low on fuel after an extended combat engagement over Germany. The weather had closed in, thick clouds, rain, visibility dropping to nearly zero, and the young American pilots found themselves scattered across northern Europe with fuel, gauges hovering near empty. The flight leader had crashed, landed on a beach somewhere in Holland, surviving but destroying his aircraft. Another pilot had bailed out over the North Sea and was never found, presumably drowned in the cold waters. One pilot made it back to England, barely, his engine sputtering and dying as he touched down. Lieutenant Roach had spotted what he thought was an airfield through a gap in the clouds. The outline looked right. Runways, buildings, what appeared to be other aircraft. He was down to his last few minutes of fuel. It was land now or bail out and lose the aircraft. He descended through the clouds, lined up his approach, and landed safely. The relief must have been overwhelming. He followed a ground vehicle that appeared to guide him to a parking area, shut down his engine, and sat for a moment in the sudden quiet of the cockpit, grateful to be alive. Only then did he realize the horrible truth. The ground crew approaching his aircraft weren't speaking English. They were speaking German. He wasn't in England. He was at a Luftwaffe base in Kassel, in the heart of Nazi Germany. German soldiers approached with weapons drawn. Roach, stunned and exhausted, raised his hands. In an instant, he went from combat pilot to prisoner of war. His aircraft, nicknamed Beetle by its crew chief back in England, was now German property. The Luftwaffe had moved with impressive speed. Allied fighters prowled the skies constantly, strafing any valuable target they could find. A captured American fighter sitting on a Luftwaffe airfield would be a priority target. Within hours, Beetle was being prepared for flight. A German pilot flew it inland to Rechlin before American or British fighters could destroy it. Now it sat waiting for evaluation, hastily painted in Luftwaffe camouflage colors with the code T9+FK, the marking of the famous Circus Rosarius demonstration unit. The original American markings were still faintly visible beneath the new paint, a reminder of the aircraft's origins. Lerche had heard the dismissive comments from other pilots at Rechlin. The P-47 was a joke. Too heavy, too big, too crude. It represented everything wrong with American design philosophy. Where German engineers created sleek, efficient fighters optimized for performance, the Americans had built this bloated monstrosity. It looked like they'd designed it by taking a radial engine and simply building the smallest possible aircraft around it, which was still enormous. But Lerche had learned long ago not to trust first impressions, especially when it came to enemy aircraft. He'd flown enough captured Allied machines to know that British and American engineers were highly competent. If they had designed an aircraft this way, if they had deliberately chosen to make it this large and heavy, they had reasons. His job was to understand those reasons, not to dismiss them based on prejudice. As he approached Beetle, he noted the sheer size of the machine. The Pratt & Whitney R2800 double wasp engine was enormous, 18 cylinders arranged in 2 rows, producing over 2,000 horsepower. The fuselage was built around this massive engine like a barrel, wide and deep. The landing gear was thick and robust, far heavier than what a German fighter would use. Everything about the aircraft screamed one word: heavy. German fighters were different. The Bf 109 was sleek and elegant, every line optimized for performance. The FW 190, with its own radial engine, still managed to look purposeful and aggressive rather than bloated. These were aircraft that had been refined through years of development. Every kilogram of weight scrutinized, every design choice aimed at maximizing performance. This P-47 looked like it had been designed by shipbuilders, not aircraft engineers. There was none of the visual elegance that German engineers prized. It looked functional, utilitarian, almost crude. Lerche began his walk-around inspection, the routine he performed before every test flight. He moved slowly around the aircraft, examining every detail, touching surfaces, checking control linkages, looking for anything unusual or concerning. The construction quality was immediately apparent, and it surprised him. The welds were clean and precise. Panel gaps were uniform and tight. The materials were high-grade throughout, good aluminum alloys, quality steel for structural components, no obvious corners cut in manufacturing. This wasn't crude construction. This was sophisticated mass production, and there was a profound difference between the two. The aircraft had been built to tolerances that German factories, increasingly stretched thin by the war and Allied bombing, were struggling to maintain. Lerche knew from reports that German aircraft quality was declining. With experienced workers being drafted for military service, with factories being dispersed to avoid bombing, with critical materials becoming scarce, German manufacturing standards were slipping. Aircraft that should have been identical came off production lines with variations that affected performance and reliability. But this American aircraft, built in a factory thousands of kilometers from any combat zone, showed the kind of consistent quality that came from undisrupted mass production. Lerche made notes in his inspection pad. This would go in his report. He climbed up onto the wing and looked into the cockpit. The canopy was large, providing excellent visibility. He could see immediately that the cockpit was huge, absolutely enormous, compared to the cramped confines of a Bf-109. A German pilot accustomed to his aircraft fitting like a tight glove would feel lost in all this space. He'd heard pilots complain about this, calling it wasteful, inefficient, more evidence of poor American design. Lerche opened the canopy fully and climbed inside. He settled into the seat, and immediately something clicked in his mind. This wasn't a flaw. This was deliberate design, and the implications were significant. In a Bf-109, Lerche, despite his small stature, had to crouch slightly to avoid continually banging his head on the canopy frame. The cockpit was so tight that accessing some instruments required awkward reaching. Long missions were physically exhausting, not just from flying, but from the simple cramped discomfort of the space. Larger pilots had it even worse, folding themselves into the tiny cockpit like contortionists. German engineering philosophy accepted this. Performance was paramount. If pilot comfort suffered, that was an acceptable trade-off. A smaller cockpit meant less weight, less drag, better performance. The pilot's job was to fly the aircraft to its maximum capability, and personal comfort was irrelevant to that mission. But the P-47 cockpit was comfortable, not just adequate, genuinely comfortable. The seat was well padded with attention paid to ergonomics. There was room to move, to stretch, to adjust position during long flights. The canopy was high and clear, providing visibility that made a German pilot's restricted view look claustrophobic by comparison. Everything was within easy reach, without straining or awkward contortions. Lerche sat there for a moment, thinking through the implications. What if American engineers weren't sacrificing performance for comfort? What if they understood something about operational effectiveness that German engineers had missed? A pilot flying an 8-hour escort mission to Berlin and back would arrive over the target, exhausted if he'd spent those 8 hours, cramped and uncomfortable in a Bf-109. Physical fatigue affected reaction time, decision-making, combat effectiveness. But a pilot who had spent those same 8 hours in a comfortable cockpit would arrive fresher, more alert, more capable of fighting effectively. Comfort wasn't a luxury. It was operational efficiency. Lerche began examining the instruments and controls, and here he found something even more remarkable. The instrument panel used color coding. Red and green sections marked acceptable operating ranges for the engine. A pilot could monitor engine status at a glance without reading actual numbers. Cylinder head temperature, oil pressure, manifold pressure, all had colored zones. Stay in the green, avoid the red. Simple and intuitive. Then Lerche understood why this mattered, and the insight was profound. According to intelligence reports, American fighter units included pilots from multiple countries: Free French, Free Polish, Czechs, men who had escaped occupied Europe to continue fighting, men whose English was minimal or non-existent. The color coding meant that a pilot who couldn't read English could still operate the aircraft safely. Green meant good. Red meant danger. Universal. Intuitive. No language required. It was brilliant. Not from a pure engineering standpoint. German instruments were more precise, gave more detailed information, but from an operational standpoint, from the perspective of keeping a diverse pilot force flying safely. German instruments required precise understanding of specifications and limits. They assumed the pilot was fluent in German, fully trained on the aircraft, intimately familiar with every system. The P-47 was designed so that a pilot with minimal training, perhaps someone who had flown other aircraft types but never this specific fighter, could operate it safely. This wasn't crude engineering. This was inclusive engineering, design that acknowledged human factors and operational reality, rather than assuming ideal conditions that rarely existed in actual combat. Lerche continued his inspection. The control layout was logical and well organized. Throttle, mixture control, and propeller pitch were grouped together on the left side where the pilot's hand would naturally rest. Fuel system controls were clearly labeled. Circuit breakers were accessible. Everything was designed for ease of use, for reducing pilot workload, for making the aircraft as simple as possible to operate under the stress of combat. German fighters were designed for expert pilots. The Bf-109 was notoriously difficult to handle on takeoff and landing, with narrow-track landing gear that made ground loops common. Inexperienced pilots crashed frequently, damaging or destroying valuable aircraft even without enemy action. But this was accepted because the Luftwaffe's training program produced skilled pilots who could master difficult aircraft, or at least it had. By late 1943, Lerche knew that the Luftwaffe's training program was collapsing. Fuel shortages meant new pilots received minimal flight time before being thrown into combat. The elaborate training pipeline that had produced expert pilots in 1939 and 1940, pilots with hundreds of hours of training, no longer existed. New pilots arrived at combat units with perhaps 20 hours of flight time, barely able to take off and land safely, let alone engage in combat against experienced Allied pilots. Germany needed aircraft that novice pilots could fly without killing themselves. But German industry was still building aircraft designed for aces, for pilots who no longer existed in sufficient numbers. America, it seemed, was building aircraft for the pilots they actually had, not for an idealized pilot who existed only in theory. Lerche went through the pre-flight checklist. The manual was clear and comprehensive, with step-by-step procedures spelled out in detail. German manuals assumed pilot expertise, using technical language and expecting familiarity with systems. American manuals assumed pilot ignorance and explained everything in exhaustive detail, as if written for someone who had never seen this aircraft before. Again, this wasn't crudity. This was pragmatism. If your training pipeline was producing pilots with minimal experience, your manuals needed to compensate. If you were fielding aircraft to Allied nations whose pilots spoke different languages, your procedures needed to be clear enough to transcend language barriers. He started the engine. The Pratt & Whitney R2800 Double Wasp roared to life with a distinctive deep sound, different from the high-pitched scream of German inline engines. The 18 cylinders fired with mechanical precision, and Lerche noticed something immediately that would become a recurring theme in his evaluation. The engine ran smoothly, beautifully, impossibly smoothly. He'd flown enough American aircraft to recognize this pattern. American engines were consistently smooth and reliable in ways that German engines increasingly weren't. German engines, particularly late in the war, were becoming temperamental. Manufacturing quality varied between factories and even between production batches from the same factory. Replacement parts didn't always fit properly. Engines that ran perfectly when new developed problems after minimal use. But the R2800 idled like it could run forever. No vibration, no rough spots, no concerning sounds, just smooth, powerful operation that spoke of manufacturing excellence and quality control that Germany was struggling to maintain. This was mass production at a level Germany couldn't match. Building one perfect engine in a laboratory was one thing. German engineers could do that beautifully. But building thousands of consistently reliable engines, with every unit meeting the same high standards, regardless of which factory produced it or which batch of materials went into it, was something else entirely. It required not just engineering skill but industrial organization, supply chain management, quality control systems that functioned at scale. America had that. Germany, increasingly, did not. Lerche received clearance from the tower and began taxiing toward the runway. Here was another revelation, subtle but significant. The P-47's landing gear was broad and robust, giving the aircraft a stable stance on the ground. The tailwheel locked solidly into place, keeping the aircraft tracking straight during taxi. Steering was positive and predictable. Visibility over the nose was excellent thanks to the raised cockpit position. Taxiing was easy. Not just acceptable, genuinely easy, even for a pilot unfamiliar with the aircraft. In a Bf-109, ground handling was a constant challenge even for experienced pilots. The narrow-track landing gear made the aircraft unstable, wanting to tip or swerve at any provocation. Visibility over the nose was terrible, requiring constant S-turns during taxi just to see where you were going. The tailwheel was small, and the locking mechanism was temperamental. Inexperienced pilots frequently ground-looped during taxi or landing, damaging the aircraft even without ever encountering the enemy. The Luftwaffe accepted these characteristics as the price of high performance. The narrow landing gear reduced drag in flight. The long nose housed a powerful engine. These were worthwhile trade-offs for a fighter designed to excel in the air. But Lerche was starting to see another pattern. Every flaw in the P-47, every characteristic that German pilots dismissed as crude or inefficient, served a deeper purpose. The aircraft was designed to be operated from rough forward airfields by pilots of varying skill levels. The robust landing gear could absorb hard landings that would collapse a German fighter's delicate gear. The good ground handling meant fewer accidents, more aircraft surviving to fly combat missions. In his later memoir, Lerche would write about once forgetting to lock the tail wheel and nearly ground-looping as a result. But the critical detail was that he caught it and recovered. The P-47 was forgiving enough that a significant pilot error didn't automatically result in a crashed aircraft. In a Bf-109, that same error would have meant certain disaster. Forgiveness. Tolerance for error. These weren't glamorous engineering goals, but in operational terms, they were invaluable. Lerche lined up on the runway and advanced the throttle. The acceleration was impressive. The massive engine pushed the heavy fighter forward with authority, the propeller biting into the air with power that was almost intimidating. The takeoff roll was longer than a German fighter. The aircraft was simply heavier and needed more speed to fly. But it wasn't excessively long. The aircraft felt solid and stable throughout the takeoff run. The P-47 lifted off smoothly, and Lerche retracted the landing gear. The hydraulic system worked perfectly, the gear tucking into the wings with mechanical precision. Every system functioned exactly as designed. No quirks, no unexpected behaviors, no systems that required careful management or special attention. As Lerche climbed to altitude, he continued testing handling characteristics. The controls were responsive but not overly sensitive. The aircraft flew with a solid, stable feel. Not nimble in the German sense, not twitchy or eager, but predictable and honest. There was no tendency to drop a wing, no quirky stall characteristics, no unpleasant surprises. The P-47 wasn't agile in the way a Bf-109 was agile. It didn't whip around in tight turns. It didn't have the instantaneous response that German pilots prized. But it was something else. It was manageable. A novice pilot could fly this aircraft without constantly fighting it. An exhausted pilot returning from an 8-hour mission could land it safely, even with degraded reactions and decision-making. This was the pattern emerging, crystal clear now in Lerche's mind. The P-47 wasn't designed to be the ultimate dogfighter. It was designed to be the ultimate operational fighter, and there was a profound difference between those two goals. Hauptmann Thurn sat on Handwerf B-1. German pilot tested, captured American P-47. Thunderbolt. What he discovered changed everything. Part 2. The truth ignored at altitude. Everything Lerche thought he understood about fighter design shifted into a new perspective. He had climbed the P-47 to 15,000 feet, then 20,000, then higher still. German fighters tended to lose performance as they climbed, their engines gasping in the thin air, power falling off as altitude increased. The Bf-109 had been designed with high-altitude performance in mind and had mechanical supercharging to help, but even it struggled above 20,000 feet. The P-47 did something different, something remarkable. As Lerche climbed through 25,000 feet, he noticed the engine still producing full power. The aircraft's performance actually improved with altitude. At 30,000 feet, nearly 10,000 meters, an altitude where German fighters were barely controllable, the Thunderbolt felt strong and responsive, as comfortable as it had been at low altitude. The secret was the turbo supercharger. Lerche knew about this system from intelligence reports, but experiencing it was different from reading about it. The turbocharger used exhaust gases to spin a compressor that forced more air into the engine, compensating for the thin atmosphere at high altitude. It was mechanically complex, adding weight and potential maintenance issues. But it worked. At altitudes where German fighters were struggling to maintain level flight, where pilots gasped for oxygen and fought controls that felt mushy and unresponsive, the P-47 flew with authority. Its engine produced power. Its controls remained effective. It could fight at altitudes where German aircraft simply couldn't compete. Lerche understood the strategic implications immediately. American bomber formations attacked Germany at 25 to 30,000 feet, flying above most of the German flak, in the thin, cold air of the stratosphere. German fighters had to climb to intercept them, burning fuel and losing performance as they clawed for altitude. By the time they reached the bombers, German pilots were already at a disadvantage, cold, hypoxic, fighting aircraft that were operating at the edge of their performance envelope. But P-47 escort fighters cruising at those same altitudes were in their element. The high-altitude environment that weakened German fighters actually played to the Thunderbolt's strengths. The turbo supercharger meant that P-47 pilots arrived at combat altitude fresh, with an aircraft performing at its best, against German pilots who arrived exhausted flying aircraft that were barely controllable. This wasn't an accident. This was deliberate design. The Americans had looked at their strategic bombing campaign and asked what kind of escort fighter they needed. The answer was an aircraft that could operate effectively at the altitudes where their bombers flew. So they built that aircraft, accepting trade-offs in other areas to excel in the specific mission profile that mattered. German fighters were designed as general-purpose tools, optimized for the kind of air combat that had been fought in World War I and the early years of World War II. Dogfights at 10 to 15,000 feet. Quick-turning battles where agility mattered most. But the war had evolved, and German aircraft hadn't evolved with it. Lerche pushed the P-47 into a dive, wanting to test high-speed handling. The aircraft accelerated smoothly, the heavy weight that seemed like a liability now becoming an asset. Gravity pulled the massive fighter downward, and speed built rapidly. The controls remained solid and responsive. There was no flutter, no concerning vibration, no sense that the aircraft was approaching any kind of structural limit. He pulled out of the dive with firm back pressure on the stick. The P-47 responded smoothly, G-forces pressing him into the seat as the aircraft's path curved from downward to level. The wings flexed but held. The structure was robust, built to absorb the stresses of high-speed maneuvering without failing. German fighters could dive well too, but there were limits. Dive too fast and structural failure was a real possibility. Pilots had to monitor speed carefully, respect red line limits, know the margins beyond which the aircraft might come apart. The P-47 felt like it could dive until it hit the ground and never exceed its structural limits. That robustness came at a weight penalty, certainly, but it also meant pilots could use aggressive tactics without worrying about breaking their aircraft. Lerche rolled the P-47, testing aileron response. The roll rate was excellent, surprisingly good for an aircraft this large and heavy. The ailerons were large and powerful, hydraulically boosted to reduce the pilot's effort. Rolling into a turn felt precise and controlled. German fighters might roll faster, but the P-47's roll rate was more than adequate for combat maneuvering. He flew for 90 minutes total, putting the Thunderbolt through various maneuvers. Combat turns, climbing spirals, high-speed runs, stalls and recovery. Every test revealed the same pattern. The aircraft never surprised him negatively. Everything worked as it should. The engine never faltered. The controls remained responsive throughout the flight envelope. Systems functioned reliably. There were no quirks, no gotchas, no situations where the aircraft did something unexpected or dangerous. And that, Lerche realized, was the point. This was an aircraft designed to be flown by average pilots under stressful conditions, perhaps damaged, perhaps with the pilot wounded or exhausted. It had to be predictable. It had to be forgiving. It had to work correctly even when things went wrong. A Bf-109 in perfect condition, flown by an expert pilot, might outturn the P-47 in a dogfight. But how often was a German fighter in perfect condition anymore? How often were German pilots truly expert? How often could German mechanics perform the precise maintenance that German aircraft required? The P-47 was designed assuming that maintenance would be performed by mechanics of varying skill levels using parts from different production batches under field conditions, possibly under enemy fire. It was designed assuming that pilots might be tired, stressed, wounded, or undertrained. It was designed assuming that aircraft would take battle damage and need to keep flying. Every design decision made sense once Lerche understood this philosophy. The robust construction meant the aircraft could absorb damage that would destroy a German fighter and still bring its pilot home. The forgiving handling meant exhausted or wounded pilots could still land safely. The intuitive controls meant undertrained pilots could operate it without killing themselves. The reliable engine meant less maintenance downtime and more sorties flown per aircraft. It was all about operational availability. Not peak performance, but sustained operations. And in a long war of attrition, operational availability mattered more than individual excellence. Lerche checked his fuel gauge. Still adequate, but time to return to base. He descended toward Rechlin, lined up for landing, and brought the Thunderbolt in smoothly. The landing was straightforward. Good visibility, predictable handling, forgiving characteristics. The robust landing gear absorbed the touchdown without complaint. He taxied back to the hangar and shut down the engine. Ground crew members gathered around as Lerche climbed out, eager for his assessment. What did he think of the grotesque American fighter? The flying milk bottle? The crude mass-produced machine? Lerche stood looking at the aircraft for a long moment before answering. The P-47 sat there on the tarmac, ungainly and fat, everything that German aesthetics said an aircraft shouldn't be. But Lerche had learned to see past aesthetics to function, past appearance to purpose. "It's the best designed operational fighter I've ever flown," he said quietly. The mechanics looked confused. Best designed? How could this heavy, inelegant machine be well designed? German fighters were sleek, beautiful, optimized for performance. This thing looked like a flying bathtub. "It's not designed for performance," Lerche explained, knowing they didn't quite understand but trying anyway. "It's designed for operations. And there's a profound difference between those two goals." He could see they didn't fully grasp what he meant. That was fine. His report would spell it out clearly. Whether anyone would listen was another question. That evening, Lerche sat at his desk in his quarters and began writing his technical report. This was always the most important part of his job. Not the flying itself, but the analysis of what the flying revealed. Anyone could fly an aircraft and form opinions, understanding what those observations meant strategically, explaining it clearly enough that decision-makers could act on it. That was the real skill. He organized his report into standard sections: performance, handling, systems, and strategic assessment. He wrote in clear, precise German, avoiding both excessive technical jargon and oversimplification. His audience included engineers who would understand technical details and officers who needed strategic context. In the performance section, he documented facts objectively. The P-47 was fast at altitude, over 700 kilometers per hour above 7,000 meters. At low altitude, it was slower than German fighters, perhaps 550 kilometers per hour. Dive performance was excellent, among the best he'd experienced. Turning performance was adequate, but not exceptional. The aircraft couldn't match a Bf-109's turn radius. Rate of climb was good, but not outstanding. High-altitude performance was exceptional due to the turbo supercharger, maintaining full power at altitudes where German fighters struggled. In the handling section, he noted the stable, predictable flight characteristics. Ground handling was easy with broad landing gear and good visibility. Flight behavior was forgiving with no tendency toward dangerous stalls or spins. Visibility from the cockpit was excellent. The cockpit itself was spacious and comfortable, suitable for missions lasting 8 hours or more. In the systems section, he detailed the color-coded instruments that made the aircraft operable by pilots with minimal training or language barriers. He described the intuitive control layout, the logical organization of switches and levers. He noted the robust construction quality, the smooth and reliable engine, the hydraulic systems that functioned flawlessly. But it was in the strategic assessment section that Lerche wrote the words that would later prove prophetic, even though they would be ignored by the very people who most needed to hear them. The P-47 Thunderbolt represents a fundamentally different design philosophy from German fighters, he wrote. German aircraft are optimized for peak performance and assume expert pilots, expert mechanics, and ideal operating conditions. The P-47 is optimized for operational reliability and assumes average pilots, field maintenance, and non-ideal conditions. He paused, choosing his next words carefully. He knew this would be controversial. He knew Nazi ideology held that German engineering was inherently superior to American engineering. But accuracy mattered more than political comfort. This aircraft is designed to be operated in large numbers by pilots of varying skill levels, he continued. The forgiving handling characteristics mean fewer training accidents and safer operations. The robust construction means more aircraft return from missions damaged but flyable. The reliable engine means higher operational availability. More aircraft actually flying on any given day, rather than grounded for maintenance. The intuitive controls mean faster training and easier transition for pilots from other aircraft types. Most significantly, every design decision prioritizes sustained operations over peak performance. The Americans have not built the best fighter aircraft in terms of raw performance metrics. They have built the most operational fighter aircraft, and they can produce it in numbers we cannot match. Lerche stopped writing and stared at what he'd written. This was the truth as he saw it, but it was a truth that contradicted everything the Nazi regime said about American industrial capacity and engineering capability. He knew there would be consequences for saying this openly. But he was a test pilot and an engineer. His job was to report facts, not to support comfortable illusions. He continued. Assessment. The P-47 is not crude engineering. It is sophisticated operational engineering. Germany builds fighters for individual excellence, for the ace pilots who can extract maximum performance from difficult aircraft. America builds fighters for industrial war, for mass operations sustained over years. If the Americans can field hundreds of these aircraft flown by adequately trained pilots, our numerical and qualitative advantages will be negated through sheer operational availability. His conclusion was stark. Recommendation: German fighter design philosophy must incorporate operational reliability as a primary requirement, not a secondary consideration. We cannot win an attrition war against an enemy who can keep more aircraft operationally available more consistently. Superior performance in individual aircraft means nothing if those aircraft spend more time grounded for maintenance than flying missions. He signed the report, Hauptmann Hans-Werner Lerche, Chief Test Pilot, Erprobungsstelle Rechlin, dated it November 10, 1930, and submitted it through official channels. Lerche's report made its way up the Luftwaffe command structure. It was read by his immediate superior at Rechlin, who found it concerning but accurate. It was forwarded to the technical office at the Reich Air Ministry, where engineers read it with interest and alarm. It eventually reached desk officers who briefed senior commanders. And then it was filed, classified, stored, forgotten. The conclusions were dismissed as overly pessimistic, perhaps even defeatist. Lerche must have been demoralized by flying enemy aircraft. Or perhaps he had been influenced by Allied propaganda. Or maybe he simply lacked proper understanding of German superiority. The P-47 was still a crude American design. Yes, it had some interesting characteristics, but German fighters were fundamentally superior. The Bf-109 and Fw-190 had proven themselves in combat. German pilots were better trained, more experienced, more aggressive. American pilots might have more aircraft, but quality would overcome quantity. That was the official position, and evidence to the contrary was unwelcome. But Lerche's predictions began coming true almost immediately, with a speed and completeness that should have been impossible to ignore, but was ignored anyway. By early 1944, just weeks after Lerche's report disappeared into the filing system, P-47 Thunderbolts began appearing over Germany, in numbers that shocked even pessimistic observers. Not dozens of aircraft, hundreds. They escorted American bomber formations deep into the Reich, flying missions that lasted 8 hours from bases in England to targets in eastern Germany and back. German fighter pilots intercepted them and sometimes shot them down. But shooting down one P-47 meant nothing when 10 more appeared the next day. The Americans seemed to have an inexhaustible supply of aircraft and pilots. German pilots reported frustration that echoed through the ranks. They would damage P-47s severely enough that German fighters would have been destroyed, only to watch the damaged Thunderbolts continue flying, limping home to England on their robust airframes and reliable engines. The pattern that Lerche had identified became brutally apparent in operational statistics. German fighters might achieve local air superiority for brief periods, but American fighters maintained strategic air superiority through sheer operational persistence. There were always more P-47s. Always. Meanwhile, German fighter production struggled. Allied bombing disrupted factories and supply chains. Critical materials became scarce. High-grade aluminum, certain steel alloys, rubber for tires. Quality control suffered as experienced. Workers were drafted into military service and replaced by forced laborers who had no investment in doing good work and often actively sabotaged production when they could. Aircraft that should have been reliable developed problems. Engines failed prematurely. Hydraulic systems malfunctioned. Electrical systems shorted out. The precision engineering that German fighters depended on was breaking down at every level of production. The operational availability gap widened into a chasm. The Luftwaffe might have impressive numbers of aircraft on paper. Production reports counted every machine that rolled out of a factory. But fewer were actually flying on any given day. An aircraft grounded for maintenance didn't count in combat, and German fighters were increasingly grounded. American units, by contrast, maintained higher operational readiness because their aircraft were designed for it. The P-47 could absorb rough handling, imperfect maintenance, and component variations that would ground German fighters. American supply chains delivered spare parts in vast quantities, ensuring that broken components could be quickly replaced. American engine overhaul procedures were straightforward enough that field maintenance crews could perform them. while German engines often required factory-level precision to repair properly. The mathematics of attrition became devastating. If Germany produced X fighters per month but only Y% were operationally available on average, while America produced 2X fighters per month with Z% operationally available, and if Z was significantly higher than Y, then America's actual combat advantage wasn't just twice Germany's production, it was much larger. Lerche continued his work at Rechlin through 1944, flying more captured aircraft and writing more reports. He flew a captured P-51 Mustang and was deeply impressed by its combination of range, performance, and handling. He flew Spitfires and Hurricanes and Soviet fighters. Each evaluation reinforced the same conclusion. Allied aircraft prioritized operational reliability in ways German aircraft didn't. He wrote report after report documenting this pattern. He explained the strategic implications clearly. He made specific recommendations about how German fighter design could incorporate these lessons. Every report was read, discussed, and filed without meaningful action. The institutional inertia was too great. The ideological commitment to German superiority was too strong. And perhaps most importantly, by 1944 it was already too late. Germany's industrial base was being systematically destroyed by Allied bombing. Even if German aircraft were redesigned with operational reliability as a priority, the factories to build them and the supply chains to support them were crumbling. The P-47 Beetle that Lerche had flown eventually went to Circus Rosarius, the Luftwaffe's demonstration unit. This unit traveled to frontline fighter bases with captured Allied aircraft, showing German pilots what they were facing and how to fight against these machines. The irony was profound. German pilots received extensive briefings on the P-47's strengths and weaknesses, learned its vulnerabilities, understood its capabilities. But their own aircraft weren't being redesigned to match the P-47's operational advantages. The Luftwaffe was teaching its pilots how to fight American fighters without giving them the tools to win that fight sustainably. By late 1944, the Luftwaffe was in collapse. Not because German pilots lacked courage, they fought with desperate bravery to the very end. Not because German aircraft were inherently inferior. A Bf-109 or Fu-190 in perfect condition was a formidable fighter. But because the industrial and logistical foundation that sustained air operations was disintegrating, aircraft sat grounded for lack of fuel. The synthetic fuel plants that Germany depended on were being systematically destroyed by Allied bombing, and there was no petroleum from natural sources. New pilots received minimal training because there was no fuel for training flights. Young men with 20 hours of flight time were thrown into combat against American pilots with hundreds of hours of experience, and the predictable massacres followed. Replacement parts became scarce. Aircraft sat awaiting components that never arrived because the factories producing them had been bombed or because transportation networks had been disrupted. Maintenance became increasingly difficult as experienced mechanics were killed or captured, replaced by barely trained personnel trying to service complex aircraft they didn't fully understand. Everything that Lerche had identified as the American advantage, operational sustainability, was absent from the German war effort by late 1944. The Luftwaffe could still launch missions, could still fight, but it couldn't sustain operations. And in a war of attrition, sustainability was everything. Hans-Werner Lerche survived the war, a remarkable achievement for any Luftwaffe pilot, but especially for a test pilot who flew over 120 different aircraft types, many of them experimental or captured machines without proper documentation. His skill and careful flying meant he never crashed or seriously damaged an aircraft throughout his entire career, a record that bordered on the miraculous. After Germany's surrender in May 1945, Lerche was interrogated by Allied technical intelligence officers. These men were fascinated by his experiences flying captured Allied aircraft. They had found his reports in German files and wanted to know more about his assessments, his conclusions, his understanding of comparative aircraft performance. An American officer, a lieutenant colonel who had been an engineer before the war, sat across from Lerche in an interrogation room. The room was comfortable, not hostile. The Allies were gathering information, not conducting a war crimes investigation. You concluded that American aircraft were superior not in performance, but in operational design, the officer said, reading from Lerche's translated report on the P-47. That's an unusual assessment. Most German pilots we've interrogated focus on dogfighting performance and dismiss American fighters as crude. Lerche nodded. He was thin from wartime privation but mentally sharp, glad to finally discuss his observations with people who might understand them. Most pilots see aircraft from a pilot's perspective. How does it handle? How fast does it go? How well does it turn? But I was an engineer as well as a pilot. I tried to understand design philosophy, what the engineers were trying to achieve. And what were American engineers trying to achieve? Sustained operations, Lerche answered immediately. Your pilots weren't necessarily better than ours, man for man. Your aircraft weren't necessarily faster or more maneuverable in pure performance terms, but you could keep more aircraft flying more consistently. You could train adequate pilots faster. You could sustain operations that we couldn't sustain. Was this apparent when you flew the P-47? Immediately, Lerche said. Within minutes of the first flight, I understood. Every design decision served operational availability. The comfortable cockpit meant pilots could fly 8-hour missions without exhaustion affecting their performance. The forgiving handling meant fewer training accidents and safer operations by undertrained pilots. The reliable engine meant less maintenance downtime. The robust construction meant battle-damaged aircraft returned home instead of being destroyed. The American officer nodded, making notes. Did German leadership understand this? Lerche laughed, but it was a bitter sound without humor. I wrote comprehensive reports. I explained the strategic implications clearly. I made specific recommendations. My reports were read and filed. The assessment was that I had been demoralized by flying enemy aircraft, that I had lost my objectivity. German engineering was superior. American engineering was crude. That was the official position, and evidence to the contrary was unwelcome. If Germany had adopted American design philosophy, would it have made a difference? Lerche considered the question carefully. He had thought about this many times in the final months of the war, watching Germany's collapse, knowing that he had seen it coming and been powerless to prevent it. By 1943, probably not, he finally said. Germany's industrial base couldn't match American or Soviet production regardless of design philosophy. We were outnumbered and would remain outnumbered. But if we had prioritized operational reliability from the beginning, from 1939 or 1940, our fighters would have been more effective throughout the war. We would have lost fewer aircraft to accidents, mechanical failures, and maintenance issues that better design could have prevented. We might have sustained operations longer, but ultimately, we were fighting enemies with far greater industrial capacity. Better design philosophy might have prolonged the war, but not changed its outcome. It was an honest assessment, perhaps more honest than the Americans expected. Lerche wasn't making excuses or claiming German superiority despite defeat. He was analyzing the situation with the same analytical precision he had brought to test flying. The interrogation revealed a pattern. Lerche wasn't alone in recognizing Allied engineering advantages. Other German engineers and pilots had written similar reports, but these reports had been systematically ignored because they contradicted Nazi ideology about German superiority and American inferiority. The numbers told a story that couldn't be disputed. The United States produced over 15,600 P-47 Thunderbolts during the war. At peak production in 1944, Republic Aviation's factory in Farmingdale, New York, was completing one Thunderbolt every hour. 63 aircraft per day, nearly 2,000 per month from that single factory. Germany, by contrast, produced approximately 36,000 single-engine fighters, total across all types during the entire war. Bf-109s, FW-190s, and various other designs, and German production was constantly disrupted by Allied bombing, by material shortages, by labor problems, but the production numbers alone don't capture the full disparity. Operational availability rates were what mattered in practice. An American fighter unit with 100 P-47s might have 85 to 90 aircraft available for operations on any given day. The rest would be undergoing routine maintenance, but the maintenance was straightforward and quick. Aircraft went down for service and came back up rapidly. A German fighter unit with 100 aircraft might have 60 to 70 available on a good day, with the rest grounded for various reasons, awaiting parts that were in short supply, undergoing repairs that required specialized skills or tools, grounded for lack of fuel. The gap between owned and operational aircraft was much wider for Germany than for the Allies. The multiplication was devastating. More aircraft produced, times higher availability rates, times better supply chains, times more reliable engines equaled overwhelming numerical superiority at the point of actual combat contact. Germany could claim impressive fighter production numbers on paper. But if those fighters spent half their time grounded for maintenance or lack of fuel, they weren't contributing to combat power. America's focus on operational reliability meant their fighters actually flew, actually fought, actually completed missions consistently. In his later years, Lerche wrote his memoir, Luftwaffe Test Pilot, Flying Captured Allied Aircraft of World War II. 2. The book provided detailed accounts of his experiences flying everything from B-17 bombers to P-51 Mustang fighters. His assessment of the P-47 included technical observations, photographs of Beetle, and his reflections on what the aircraft represented. One passage captured his final understanding. The P-47 Thunderbolt was not the fastest fighter, not the most maneuverable, not the most elegant, but it was the most operational. And in total war, operational availability matters more than peak performance. The Americans understood this. We did not. That difference decided the war in the air. What makes Lerche's story important isn't just that he flew captured aircraft. Many pilots on both sides did that. It was routine to evaluate enemy equipment when it fell into your hands. What makes his story significant is that he understood what he was seeing. As a trained aeronautical engineer and experienced test pilot, Lerche could evaluate not just whether an aircraft was good or bad in some abstract sense, but why it was designed the way it was and what that revealed about broader industrial and strategic philosophy. The P-47 Beetle that Lerche flew on November 10, 1943, represented more than just one captured fighter. It represented a completely different approach to warfare. Germany approached World War II as if it were still World War I at scale, where individual excellence and superior technology could win battles decisively. Small numbers of expert pilots in high-performance aircraft could dominate through skill and aggression. America approached World War II as industrial war, where sustained operations and overwhelming numbers deployed consistently would win campaigns and, ultimately, the war. Adequate pilots in reliable aircraft, deployed in numbers that could be sustained indefinitely, would grind down any opposition through sheer attrition. German fighters were magnificent machines when everything worked perfectly. The Bf-109 and FW-190 were genuinely excellent aircraft, capable of extraordinary performance when flown by skilled pilots, maintained by expert mechanics, and supplied with quality fuel and parts. But, when everything worked perfectly, became increasingly rare as the war progressed. Manufacturing quality declined as German industry was bombed and disrupted. Expert mechanics were drafted or killed. Quality fuel became unavailable as synthetic fuel plants were destroyed. Replacement parts were scarce. The entire support infrastructure that allowed German fighters to perform at their peak was crumbling. The P-47, by contrast, kept flying. It absorbed damage that would destroy other aircraft and brought pilots home. It operated from rough forward airfields without specialized support equipment. It could be maintained by mechanics of average skill using standard tools. It could be flown safely by pilots with modest training. And, most importantly, there were always more of them. Lerche had recognized this pattern immediately. On that November afternoon in 1943, his 90-minute flight had revealed fundamental truths about design philosophy and industrial warfare. His report had accurately predicted what would happen over the next 18 months, but his report had been filed and forgotten because the truth was inconvenient. It contradicted Nazi ideology about German superiority. It suggested that the war might be unwinnable. It implied that American industrial capacity was not just larger, but better organized and more effective. So the report was ignored, and Lerche watched his predictions come true as the Luftwaffe was ground down by an enemy that could simply keep more aircraft flying more consistently. He watched young pilots die because they were flying temperamental aircraft they weren't properly trained to handle. He watched experienced pilots return from missions reporting that they had damaged or shot down P-47s, only to face more P-47s the next day. He watched Germany lose the air war not because German pilots lacked courage or skill, but because German industry couldn't sustain operations against an enemy that had built sustainability into every design decision from the beginning. The lesson is timeless, extending far beyond World War II aviation. In any sustained conflict, military, economic, technological, reliability beats peak performance. Operational availability beats maximum capability. Sustainability beats excellence. And design philosophy that acknowledges real-world constraints and human limitations will outperform design philosophy that assumes ideal conditions and perfect execution. The P-47 Thunderbolt wasn't the best fighter of World War II by any single performance metric. It wasn't the fastest, wasn't the most agile, wasn't the most elegant. But it might have been the best designed fighter because it was designed not for air shows or test flights or record-breaking demonstrations. It was designed for war, real war, long, grinding, attritional war, where the side that can keep fighting longest and most consistently wins. Germany built fighters for aces. America built fighters for armies. And when those two philosophies collided over the skies of Europe from 1943 to 1945, the outcome was never really in doubt. Lerche saw it in 90 minutes. History took 2 years to prove him right. But he was right from the beginning, and his ignored report remains a testament to what happens when inconvenient truths meet comfortable illusions. The side willing to face reality, even when reality is uncomfortable, has an advantage that all the engineering excellence in the world cannot overcome. And sometimes, the most important discoveries aren't made in laboratories or on drawing boards. Sometimes they're made by a test pilot climbing into an enemy aircraft with an open mind and seeing what's actually there, rather than what ideology says should be there.